Okay, we're going to look at trigonometry in right triangles today. And we're going to first talk off by the 6 trigonomic functions. So last year in geometry we talked about that the 3 main ones, sine, cosine, and tangent, and how a lot of people use this SOHCAHTOA. And sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So then we have these 3 others that are just reciprocals of these. So cosecant is a reciprocal of sine, so it's hypotenuse over opposite. Secant is reciprocal of cosine, and cotangent is reciprocal of tangent. And we really don't see these too much until we get a little bit higher, even more higher in math, but we do want to make sure we know these and who their opposite is, who their opposite buddy is. So want to make sure we have those. So first off, it's just writing our trig ratios. So angle G is where we're at to talk about. This is our angle of perspective, and what side is opposite of me is the side that's not touching me, so 24 is opposite. And the hypotenuse between these two, they both could be considered adjacent, but the one that is truly adjacent is 32, because 40 is the hypotenuse, and the reason we know it's the hypotenuse is because it's opposite of the 90 degrees. So my sine of angle G is opposite, so 24 over my hypotenuse 40, which we would want to reduce that to 3/5. Cosine of my angle G is adjacent, so 32 over 40, which would reduce to 4/5. And tangent of angle G is opposite, 24 over adjacent, 32. So 3/4. So then we have the other 3 that are just reciprocals of these, because cosecant is reciprocal of sine. So cosecant would be 5/3. Secant would be reciprocal of cosine, so it'd be 5/4. And cotangent is the reciprocal of tangent, so 4/3. So go ahead and let you figure out that next one. Here we're given that we're given one ratio, and we know again that the ratio is opposite, so tangent is opposite over adjacent. So we're given the adjacent side and the opposite side to A. So I can draw my triangle any way. I know A is acute, so it's not the 90, but other than that, A could be here or it could be up here. I'm just going to put it there. So opposite of A is 5. We knew that again because this was tangent, and tangent is opposite over adjacent, and adjacent to A is 3. We want to know what cosecant A is, and cosecant is hypotenuse over opposite. So we don't have the hypotenuse, so we need to find that. We can use Pythagorean theorem. So 3 squared plus 5 squared equals our hypotenuse squared. So 9 plus 25 equals hypotenuse squared. So 34 equals hypotenuse squared. So hypotenuse equals the square root of 34. So cosecant is hypotenuse over opposite, so it's the square root of 34 over 5. So that's just using those ratios. Next, we're going to look at using those ratios to find missing sides and missing angles. So here's where my angle is, so we're going to use that angle. X is opposite of me. This is how we determine which trig ratio to use. 12 is the hypotenuse because it is opposite of the 90 degrees. So the trig ratio that uses opposite and hypotenuse is sine. So sine of my angle, which is 60, equals opposite over hypotenuse. Multiply both sides by 12. plug that into your calculator and you should get 10.4. If you don't get 10.4, your calculator might be on radians, which means you might click mode and go down and check and make sure that it's not on radians. We want it on degrees. All right, so we have a lot of examples here. I'm not going to work through too many of them. I'm going to skip a few and talk a little bit about finding missing angles, and then we'll look at a couple more examples. So when I'm looking for missing angles, I want to use the inverse. So remember, inverse is what I plug in what I answer was, I get what I started with. So in this case, the inverse of the ratio would be the angle. So when I put the angle in, I get the ratio. Now when I plug in the ratio, I should get the inverse. And we use these -1 powers. And to get that, it's second, and then sine, second, cosine, depending on which one we're using. And then of the ratio, then will give me the angle. So it's the inverse of it, the undoing of it. So we're finding the measure of angle A here, and we can really use any two sides that we want. Let's use 9. So 9 is opposite of A, and 17 is my hypotenuse. So if I use those two sides, a lot of times they'll just give me two sides. Then I want to use sine, and since I'm using angles, I want to use inverse sine. So inverse sine of 9 over 17 should give me my angle 32 degrees. And then angle B, so if this is 32 degrees, angle B would be 90 minus 32, because the angles add up to be 180, so 58 degrees. Okay, let's look at this one. Mario hits a line drive home run from 3 feet in the air. So when he hits it, it's 3 feet up. Line drive, so it's going straight to a height of, oops, it's a line drive. So it goes to a height of 125. If the angle of elevation was hit at 22 degrees, what is the horizontal distance from him to the billboard? So we're looking here for this. So we want to go, this is opposite, and this is adjacent. So we would use tangent. So tangent 22 equals 125 over x. So we're going to multiply both sides by x. So we have x tangent 22 equals 125, and then divide by tangent 22. You get 309 feet. All right. Well, that is that lesson. It's kind of an overview, kind of skipped around, so if you have